Okay, so let me just show you the formula sheet. Here's the formula sheet, guys. So we're gonna be using the formula sheet. It's at the end of your assignment. If you go to your tutorial letter, you'll see the formula sheet. Everything is there. So now we're gonna use this table of integral today. We're gonna be using this table of integral. I'll take you through every equation or formula. So I'll take you through every equation. We'll stop here at number 5. This is where we're gonna stop. We're gonna stop at number 5 because this from number 6 going downwards, that's a trigonometric function. So today I want us to do the standard ones and the logarithmic ones. Yeah, that's all we're gonna do today. So all I can say is that integration, guys, it's the reverse of derivative, your differentiation. So it's the reverse of your differentiation. I'll just show you one example. I'll just show you one example just now. So we're gonna do number 1, 2 up until number 5. Then number 6 we'll do it on the next session because I don't want to confuse you guys. I know you guys are, this is the first session for integration. Like this is your first class for integration. So for those who are doing maths 2, at least they have a knowledge of integration from maths 1, this maths that we're doing now. So for you guys, we're gonna do the basics. So I'll just show you one example, guys. Let's say, for instance, I'll just start with differentiation. I'll just show you the relationship between integration and differentiation. So let's say you are given x cubed. So they say find dy over dx. So we all know that when you differentiate, guys, this is the formula for differentiation. So you're gonna say nx to the power n minus 1. I told you guys on the previous session that you multiply by d over dx, and then you write your f of x there. I hope you guys remember this from the previous session. If you're not here last week, I've uploaded a video. We'll just share the link for the YouTube video. I think it's 55 minutes long or more than 55 minutes. I can't remember, but it's long. It's the whole session where we were covering the differentiation and everything. Even some of your assignment questions, we did them. Yes. So if you're not familiar with differentiation, please go check that video. It's under Maths 1. I just showed you guys where to find them. So this is how you differentiate. So for integration, guys, for integration, I'll just write this sign like S. It looks like S. This is integration. You find that sign here. Let me just show you on the formula sheet. This is the sign. This sign here, guys. On number 1, do you see that sign like S? This is integration. This sign means integration. So you just put that sign when you integrate. So let's go back. Okay, let's go back here. So for integration, guys, I want you to give me the before you do the integration, I want you guys to give me the differentiation of x cubed. What is the differentiation of x cubed? Anyone to answer that? Thank you. Thank you. So remember, I said you multiply by d over dx. The reason why they didn't do this, your f of x is this, your function of x is this. You ignore the 3 cubed, you take this. This is your f of x. This is your f of x. So you're gonna multiply by that dy over dx of f of x. So your f of x is x. So when you differentiate x, guys, you're gonna get 1. Those who are here, they know it's 3x squared multiplied by 1. So that's why they don't write this. On your formula sheet, they didn't write this, but then always write it. So guys, you see here we're multiplying by this. We're multiplying by f of x. For integration, we're gonna divide. So let me just show you the difference. Okay, let's say they give you something like this. Let's just integrate this thing, this x cubed. Write x cubed. When you integrate, guys, you write this sign of s, and then you say dx. This dx means you are integrating with respect to x. Like when you differentiate it, you're divided by this, meaning you are differentiating with respect to x. So for integration, this is the standard formula. You have to, when you differentiate when you integrate with respect to x, you have to write dx there. If you don't write dx and write this like this, if you write it like this, x cubed, you're not integrating. That's wrong, because you don't tell, you didn't specify what function are you integrating with respect to. You must specify that I'm integrating with respect to dx, like you specified when you differentiated that you are differentiating with respect to x. If let's say this, instead of x the root t cubed, it means you have to integrate with respect to what? To t. So you write dt there. Do you guys understand that? Thank you. Thank you. So now, guys, here we're gonna apply this formula. Let's just do number one. Let me just take you to formula number one. Do you see formula number one, guys? This is the standard. This is the basic. This is where you start. The reason why they wrote this formula like this, it's for a reason. It's for a good reason. So it builds up. Number one then goes to number two. So there's a reason why they wrote them like this. So now let me just explain formula number one for you to you guys. This is the formula that we're gonna use on this question that we are doing now. So let me just go to the next slide. I'll just rewrite that question. It's integration of x cubed dx. So for integration, guys, remember for differentiation we said it's x n minus 1. Okay, sorry, I didn't multiply by d over dx f of x. So for integration, guys, for integration, this is der. I'll just write der for derivative, int. I'll just write int for integral. Okay, so for integration, guys, you're gonna say x to the power n plus 1 over n plus 1. So basically, instead of subtracting here, you add. And then for this one, you don't multiply by n, you divide by this exponent. You divide by the exponent. So basically you add 1, then from there you divide by the exponent. You bring this exponent down. Then, like I said, remember here you're multiplying by d over dx. So here you're gonna divide by d over dx. You're gonna divide this whole thing, like you're gonna, instead of multiplying, sorry, let me just write that line nicely. Instead of multiplying by d over dx, you're gonna divide by d over dx. So just do this over dx. F of x, sorry, you have to write f of x there to show that you're differentiating your f of x. F of x is, this is the formula for standard integration. So if we apply that formula there, if you apply it here, you'll get, when you integrate, guys, the moment you start integrating, you remove this sign. Remember, the moment you start integrating, you have to remove this sign. And then from the differentiation, you get y, x cubed. The moment you differentiate, the moment you say dy over dx, it means you're applying the integration, the differentiation, I mean. So you have to write your answer. It means you have to write your answer. You cannot say dy over dx, then write x cubed. No, that's wrong. The moment you introduce the differentiation, you write your answer, because it shows that you have applied differentiation. So the moment you integrate here, you write, you remove this integral sign. So you're gonna say x cubed plus 1 over 3 plus 1. Okay, multiply by d, oh sorry, there's no space, I have to do this. Okay, guys, remember I said you divide, so this is the same as 1 over d over dx. It's the same. So your d over dx, as you can see, guys, your f of x is it's x, so you can put x there. This is your f of x. So now the answer that you're gonna get here, you're gonna get x to the power 4 over 4. They normally write plus c. They normally write plus C. If you go back to your equation, to your formula sheet, I mean, do you guys see that plus C at the end there? Yes, they normally add plus C. It's a standard formula. It's a standard rule. I don't know why they're adding plus C, but then that's how they do it. That's how they do it. Any question, guys? Any question? Any question? I'll do the next example with you guys because I want to be sure that you guys understand the basics of integration. Sorry? Yeah, this is from your formula sheet like I showed you now. It's always when you integrate, you have to always put plus C. When after integrate, when you get your answer. You see, let me show you. This is how you get your you see like number one. Let's go to formula number one. They are saying integration of ax to the power n. It's like ours a, in our case a was 1 and then x was x cubed. You see that dx there. So now the answer that you must get is on the right hand side. So you must get this answer. This is the answer. So you just substitute your values on the right hand side. You see it's equal, there's equal sign there. This equal sign. It shows that the left hand side of your thing it's equals to the right hand side, like with your differentiation. So your answers are on your right. So whatever that you're doing, you must get this with a plus C there. It's a standard rule. Sharp, sharp, not a problem. The moment you get a question, if you don't understand the question, when you don't understand the question, please go to your formula sheet, go check where which go check. Like if you check this, it's integration of x cubed. So you know here there's 1, but you didn't write 1 there. So if you go to your formula sheet, you'll see which rule do you have, which formula do you have to apply. If you go there, you'll see, you'll check for something that has got x to the power something, which is formula number 1. Do you guys get that? Yes. The moment you get a question, let's do this one. Let me just show you from your study guide. I think there's do you see this question, this integration of 2x, integration of 2x. Let's just go there. I'll just show you now. Integration of 2x. Okay, they are saying they want integration of 2x. If they say find integration of 2x, you have to write dx there. So all you have to do, remember, these 2 is a constant. Like even when you're differentiating, the number before a function, like a function of x or any function, it's a constant. So you treat it as a constant. So you can ignore that 2, you just keep it there. So you apply that rule. Remember I said you add 1. So this is to the power 1. So now when you integrate here, you're going to apply the first formula. Look at this. This is the same as integration of a x to the power n dx. And then let's go to the formula sheet. They told you that this this thing this thing is the same as ax to the power n plus 1 over n plus 1. Do you guys see that plus c? They put plus c there. Do you guys get it? Does it make sense, guys? Thank you. Thank you. The reason why I'm doing this integration, guys, it's because of your assignment. I understand that we skipped L hospital rules and all those other rules. We'll get back to those chapters. I understand that we have to do them, but then at the moment, your assignment 4, yeah, it's assignment 4. It covers integration. So rather do integration because the all hospital rule it has got nothing to do with it. Integration, it's a different chapter. They don't link. They are not connected. So the reason why I skip those chapters is because of differentiation and integration. They are related. Do you guys see that? Hello? How? Yes, and that's the reason why I skipped those things, those L'Hospital rules. I'll go back to them later. For now, let's cover the assignment and get this going. So now they are saying we must get ax to the power n plus 1 over n plus 1 plus c. But then before you write plus c, guys, remember what I told you guys. You have to say multiply by 1 over d over dx f of x. You will see why I'm writing this d 1 over d over dx f of x when we do the application. When we do the applications of integration, you'll see the necessity of this thing. For now, it doesn't make sense why I'm adding this, but then you'll see later. So, guys, please let me know if I'm too fast or maybe if my network is too bad. Because, yeah, please let me know. If you can't hear me, please let me know. If there's a delay with the network, please let me know. Then I'll make a plan to try and fix it. So, the answer that we're going to get, yes. Can someone tell me the answer without looking at in the study guide? Can someone give me the answer? Integration of 2x, what do you get? Hello? What is the integration of 2x? Can you guys hear me? Can you guys hear me? Yes, I'm asking, like, applying this formula. Applying this formula, guys. This one. This formula. What is the integration? You just substitute your values there. What is the integration? This is your a, this is your x, there is your dx. So they are saying you must get this. So what's the answer? Over 2 plus c. That's correct. And then as you can see, guys, this 2 and this 2 and this 2 will cancel. So this will be equals to x squared plus c. Yes, that's correct. That's correct. So I hope this makes sense, guys. I'm just doing the basics, guys. We won't do the applications today. We'll do the applications later. So let's say you have got integration of 2 dx alone, guys. You know, from differentiation, guys, when you differentiate a constant, let's say y equals to 2. So they say differentiate 2. Remember, always it has got x to the power 0. If it's a number alone, it's always x to the power 0, because this x to the power 0, x to the power 0 is like 1. So basically, it's like you're replacing this by 1. So just write x to the power 0. So when we apply that differentiation rule, here you're going to get a 0. How? When you say dy over dx, you're going to take this. This is your n. Remember, this is your n. So you're going to say n x to the power n minus 1. Okay? Then your n is 0. You're going to say 0 multiplied by everything. So everything multiplied by 0, obviously, guys, you're going to get a 0. X to the power 0 minus 1. Doesn't matter. So for the fact that you're multiplying everything by 0, you'll get a 0. So when you differentiate a constant, you get a 0. But then with integration, when you see a constant like this, please add, please know that there's a x to the power 0. Remember, with integration, you're adding 1, you're not subtracting 1, and you're not multiplying by 0. That's the difference. Do you guys see the difference? You're not multiplying by 0. So, can I ask someone to answer this question? What's the answer when you integrate a constant, a number alone? What are you going to get there when you apply that rule? This rule still applies. This is your n, 0. Then there is your a, 2. And then there is your x. There is your dx. You just look at the formula, guys. Then, yeah. What's the answer, guys? Anyone to answer that? Sorry? You'll not get what? No. Apply these rules. The rule that I don't know if it was you. The rule that we applied here, please apply it here. Please apply it here and tell me the answer. That's correct. And then what are you going to get? You're going to get 2x, right? Yes, that's correct. You're going to get 2x to the power of 0 plus 1 over 0 plus 1. So you're going to get 2x to the power of 1 over 1, which is 2x plus c. Do you guys see that? Thank you. So that's your basics of integration. If you look at if you check your study guide, there's a couple of them. Like there's your constant here, number b, there's your constant, there's your 2x. Yeah, we'll do a lot of them, don't worry, we'll do a lot of them so that you guys can understand. There's a lot of them, there's a lot. So I don't want to jump into the applications. I just want to do the basics with you guys. Just want to do the basics. Let's do the second example and like the third example. Does anyone have a question before we move to the next example? Yes. We're integrating. Remember, this is integration. This means integration, and then this means differentiation. So there's a difference between, okay, let's go here. We have got y equals to 2x, oh, sorry, 2. We've got y equals to 2. So when you differentiate, if they say differentiate 2, you're going to say dy over dx equals to. Do you remember? Okay, let me just ask you this question. What is the differentiation of 2x cubed? What is 6x squared? Thank you. Because you applied this formula right here, right? Okay. So when you integrate, you don't apply that one. You apply this one. X to the power n plus 1 over n plus 1. It's your formula number 1. That's the formula that you apply when you integrate. So there's a difference between integration and differentiation. Do you see that when you differentiate, this power, let me do this, this power, it decreases because you're subtracting 1. It decreased to 2. So, but then when you integrate, it goes up with 1. You are incrementing it. You are adding 1 to the power. Do you get that? Do you get that? So let's go to a constant now. Let me just erase this. I'll write it nicely. So when you differentiate a constant, dy over dx, remember what I said, 2x to the power 0. Do you agree that 2x to the power 0 is the same as 2? Okay, so what are you going to get when you differentiate this? Yeah, you're going to get a 0. Okay, let's go to integration. Integration, you're going to do this and write 2 dx. So now, when you integrate, you're going to apply this formula right here instead of decreasing by 1. So you can simply write this like this, 2x to the power of 0. Do you agree that is the same? Is the same as 2x? So when you integrate, you add 1 to the exponent. So you're going to say 2x to the power of 0 plus 1 over 0 plus 1. So that's the difference between integration and differentiation. So for this one, you're going to get 2 to the power 1 over 1, which is the same as 2x plus c. Do you see it now? Yes, for integration, when you integrate a constant, you're going to get a constant multiplied by a function of x or t. It doesn't matter, that function. So for integration, you are adding 1. For differentiation, you are subtracting 1. And for integration, you are dividing. For differentiation, you are multiplying instead of dividing. Yeah, that's the difference, guys. Does anyone have a question before you can proceed? Any question, guys, where you need clarity? please let me know. Is there any question? Please ask. Please ask if you've got any question. Okay, no question. I'll do the next example, guys. The next example, guys, let's say you've got this 3x squared plus 2, and then they say dx. If you've got something like this, guys, you know that, let's say you've got something like this. This is the same as, maybe, let's say you've got 2x into 3x squared plus 2. And then this side, let's say you multiply it by 3. So basically what I mean by that, this 2x represent your integral sign. Then this 3, it's your dx. So when you've got something like this, guys, to solve, maybe let's say they said solve for y. They said solve for x, or factorize or simplify or expand. Doesn't matter it doesn't matter what question it is for now. First thing first, you have to factor it out. Like basically you need to multiply it out. You remove the brackets. So you're gonna say, it's up to you, guys. It's up to you. So what I can tell you guys is that, multiply by the first one from this side. Multiply by the first one from your left hand side to the right hand side. You move your right from the left to the right. Even if you're using left hand, even if you're using left hand, there's no way you can write from the right to the left. Or is there anyone who does that? Maybe I'm wrong. Hello? Yes. So I just wanted to be sure before I'm assuming something wrong. Okay, so now let's say you're gonna remove the bracket. So you're gonna multiply by 2x. You're gonna say 2x multiplied by 3x. Okay, basically, no, there's no need for me to write everything here. Let me just do this. So you're gonna multiply this by this. So you're gonna get 6x to the power 3. Here, guys, you need to know your basics of exponential rules. Where you're multiplying the parts of the same base, you add the exponent. Dividing the parts of the same base, you subtract the exponent. Yeah, you need to know those. Yeah. So then I'll say 2x multiplied by 2. Then I'll get 4x. Then we still have 3 outside. So now we move to the right now. We are moving from left to the right. So we're going to multiply by 3 now. It's 6. Sorry. Let me just write the final answer. So you're going to say 3 multiplied by this, and then 3 multiplied by this. So you're going to get 18 there, cubed, plus 12x. This is your answer. So guys, the reason why I did this is because of this. As you can see, guys, there's a bracket here, and there's two variables inside the bracket. So what I mean is that you need to multiply out. So you're gonna say integration of 3x squared. So basically you're gonna do this. You're gonna multiply by this, and then also by this. As you can see, they're outside the brackets. So you're gonna start with this first. Okay, then here you're gonna get dx. Okay, you're done. Then now you're here. So remember, everything is it's inside the brackets. So you do the same with this one. You're gonna say plus. Then let me use a different color. Let me use yellow. I think yellow will do. Then you're gonna do the same again. This multiply by this, and then this multiply by this. So basically you're removing your brackets. So it's 2 dx. Do you guys understand it? Do you? Sure. Not. Which No, I was just showing you how to multiply out if you have got something like this. That's why I even specified here. I even wrote here. The reason why I did this, it's because of this is the same as this. So I just wanted to show you using the basics, that this 2x here represent integral sign, that integral sign. Then this 3, it represent dx. I was just showing you, this is an example. I was just showing you how you're going to multiply out so that you don't ask me, why did you multiply everything by dx and integration here? This is the same thing. Do you get it? It's the same thing as whatever that I did now. What's your confusion? On the left, you mean this side? Please ignore this side. Please ignore this side. This right hand side, it was just an example. I was just showing you that this was just no. This was an example. I did say it, that here, this whatever that I'm doing here, it's an example to show you guys the applications. That's why I said you let, like for example, I said integration, it's represented by 2x. I'm not saying this is the same. No, this was just an example to show you how I'm gonna multiply out everything. Let me just erase it so that you guys don't get confused. Let me just erase it. I was just showing you guys how to multiply out, so that it will make sense when I multiply out the integral sign and the dx. Focus on the left hand side. This one you must ignore it. Yeah, this one we're not gonna use it. So do you understand this part? Okay, so please integrate this. What are you gonna get? First thing first, guys, let me tell you something. Before you can integrate, simplify always. Even when you're doing your differentiation, you have to simplify first. So always, before you solve anything, please simplify it, then solve. Do the applications. You cannot do applications without simplifying. So you expand this thing, and then once there's nothing you can do, then that's when you do the applications. Do you guys understand it? Does it make sense, guys? Thank you. So yes, please give me the answer. The person who answered yes, please give me the answer. Please give me the answer for this one. Let me give you a hint. Here's the formula. This is what you must get. Axn plus 1 over n plus 1 plus c. Please give me the answer. This is the answer that you should get. Your a, okay, this is the same as integration of ax to the power n dx. Please give me the answer applying this formula, because this is in your formula sheet. So I'm just writing it on the side there. Please give me the answer. What are you gonna get? Inte I think there's someone who has got a question. Let's attend that person first, then we'll give me the answer. What's the question? What? No, it's just 3x squared. No, this plus 2, it's a separate. You see this plus, it's not squared. Look at this plus, it's down. Look at this question. You see this, it's not up here. 3x squared. If it was 3x squared plus 2, it was going to be like this. So it's not like that. This plus 2, it's down. It's down. This is your base. This is your base. This is your base. Sharp. Please give me the answer. And remember, let me give you a hint. Remember, it's a constant, so it must be to the power 0 there. So please give me the answer. What's the answer? Applying this formula, apply this formula. You just go to your formula sheet, you'll see this formula. Three x cubed. Wait, why is it over 4? Th Thank you. No, don't add plus c here. Add plus c at the end. Just add it once. 2x plus c. Thank you. You just add c once at the end of the equation. That's correct. Then this 3 and this 3 will cancel. Then you'll get x cubed plus 2x plus c. This is your answer. This is how you get your integration. Does everyone understand that part? Does everyone understand it? Yes, no? Sharp. I want to be sure that everyone understands this. Otherwise, guys, I'm gonna do this. You know, if those who were attending last time, they know me. I just pick a random person, so I'll just pick a random person. I'll do an equation. You have to solve it for me to be sure that I don't want us to move without others understanding. So the main thing of doing this is for you guys to understand. So I'm gonna select a random person to be sure that you guys understand this. I'll give you an equation just now. So before we can do the division, right now we are doing the addition. So we're gonna move from addition to subtraction to division to multiplication. So right now we are doing addition. After addition, remember we started with the number. A number, it was added to 0. So it was a number, addition. Then we're gonna do subtraction. After subtraction, we do division. After division, we do multiplication of integration. So right now, I'll give someone, before we move to the subtraction, I'll give someone a sum or a question. So say you have, what can I say? I'm thinking. Okay, let's say you have 3x to the power of a. Okay, let me do this plus. What can I write here? I just want to write something. Plus a dx. There's no difference between whatever that we did previously and now. It's the same thing. Let me just pick someone. Let me give you a hint. You see this a? Can someone tell me what's this a? From the previous example, what was this 2? Okay, so what's this a? Remember, no, it's a constant as well. A, it's a constant. Remember, a constant can be, no, it cannot. This is a different question, guys. Please don't confuse. The reason why I went back is because I wanted to ask you a question. Please don't confuse the two. This is a different question. This is a new question. It has got nothing to do with the previous questions. I'm just showing you guys. This a, it's a constant as well. This is a constant. This is a constant. It's a variable, this thing. So it's the same as a number. So you can replace a by any number. So a is a number. It's a you can consider it as a constant. Do you guys get it? Yes. So a it's a constant. Please apply this rule. Let me see. I'll pick Ndlovu. Is it Ndlovu? Slindile. Is it Slindile? Slindile. I'm struggling to I'm struggling to pronounce your name. You made your name long. because I'm Pedi, so this name is long. Slindile. I had to struggle. Slindile. Your surname is Izindlovu. Slindile. Yeah. Slindile means waiting, waiting, right? Okay, so Slindile, please apply this rule like ax n plus 1. You have got the formula, guys. You have got the formula sheet. So there's no need for you to struggle. Please apply this formula. Give me the answer here. What do you do? Talk to me. Let's work together. Talk to me. What do you do? First step, what do you do? When you find the brackets, what do you? Yeah. Ax. Okay. Okay. Thank you. That's correct. That's correct. Do you guys understand it? This is correct. If the reason why I'm writing a, guys, they can give you any variable. They can give you any variable. I just wanted to show you that even if they write a there or b or any function, it's a variable. Even if they're right, let me show you something. Let me show you guys. Let me show you guys the second example. I know we're gonna move to the next example. I just want to be sure that you guys understand this. This lean, this is lean. They call this lean. Remember when you're doing differentiation, you have to differentiate lean. Lean. If you punch lean on your calculator, obviously you'll get an error with lean alone. Lean is a number, guys. Lean, it's a number. It's a function as well. So you get lean here. So this, if you get lean alone without x, then you know lean, it's a number, it's a function. If you get something like this, it's a function. So basically you're gonna get 3x lean plus 1 over lean plus 1 plus lean x. This is how you do it. I'm just showing you guys, just sharing. This is a additional information. They normally give you something like this. They can give you a lean. Just know that lean is a variable, it's a number. Do you guys get it? Thank you. Thank you. Does anyone have a question before we move on? Even those who just joined? Does anyone have a question? Okay. Then if there is no question, guys, please slow me down if I'm too fast. Please slow me down. Okay, let's do the subtraction. I'll do one example for subtraction, guys. There's no need for me to do a lot of examples. So let's say I've got minus 3x minus 5x to the power 4, and then dx. So guys, this is the same. This is the same. You do the same thing, guys. You don't ignore the sign. You just do the same thing. You'll just write minus 3x to the power of 1 plus 1 over 1 plus 1 minus 5x to the power of 4 plus 1 over 4 plus 1. So there's nothing different here. Do you guys understand it? Plus c there. You add plus c, then you'll solve it. I hope it makes sense, guys, because there's no difference. I just wanted to show you that there's no difference between the two. You just apply the same rules. Make sense? Does it make sense? Yeah, that's the difference. I just put minus 3 instead of plus 3. So that's the difference. So let's say I've got this, not a problem. 5x to the power minus 4. So here, guys, you just do the same. Obviously, when you add plus 1 there, you'll get you'll say 3. Oh, sorry. Let me remove that integral sign. when you integrate to remove the integral sign, it's 3x to the power of minus 1 plus 1 over minus 1 plus 1 plus 5x to the power minus 4 plus 1 over minus 4 plus 1, and then plus c there. Then your final answer will be 3x to the power of, when you say 1 minus 1, you'll get 0 there, then you'll get a 0 there. This is undefined. This is undefined. Do you guys see that? This is undefined. It's an undefined. So there's no need for you to memorize this. It's very rare to get a question like this. A question where you divide by 0. It's undefined, but then there's no way you're gonna get it. For you, in your case, I just wanted to show you the subtraction. The main reason of doing this is this negative there. This negative exponent. That's the main reason why I'm doing it. So there's no way you'll get something like this. They can't give you something like that. The aim of doing this is to show you guys that when you subtract there, you're gonna get 1 minus 4, you're gonna get minus 3 over minus 3. So here you can write, remember guys, this is the same as minus 5 over 3 x to the power of minus 3. How can you write this? The reason why I'm doing this is because of this thing. How can you write this? If they say simplify further, how can you write this? Hello? Are you guys still there? Or is it my network? Hey, guys, can you hear me? What's confusing? Ignore the okay. Ignore the undefined. Okay, maybe this is what confuses you. Ignore the undefined because it's very rare to get that question. Okay, okay, let's do this then so that you don't get confused. Let's do this. Let's do this. Let's remove this. Let's remove this because yes, I think it's confusing. When you integrate this, do you agree that you're gonna get this? Okay, so what I'm asking is that the main reason of me doing that is because of, they will say simplify further. So how can you write this answer? This minus, okay, maybe I must write it here. Minus 5 over 3 x to the power minus 3. Do you agree that this is the same as this? So I'm asking, simplify this further. Do you see, get rid of this negative exponent? How can you get rid of that? How can you write your final answer if they say simplify further? Okay. Okay, let's go here. If they say x to the power minus 1, thank you. Thank you. Thank you. What? Let me just explain to them. You are right. That's correct. You need to know, guys, with this maths, you need to know exponential rules. What is 1 over 1? What is x to the power minus 1 in standard form, not in exponential form? This is exponential form because it's raised to the power something. So you need to write it in a standard form. So when you write this in a standard form, it's 1 over x to the power 1. Do you agree? Yes. So let's go back. How can you write this in a standard form? Not in exponential form. It's in exponential form. So how can you write it in a standard form? This right here. Thank you. So basically you'll get minus 5 over 3 x cubed. That's correct. That's correct. That's correct. What she was saying is that you're going to say You keep this as a constant, 3, then you multiply by 1 over x cubed. So when you multiply this, you know this and this multiply, then this and this multiply. Do you guys see that? Okay, thank you, thank you, thank you. Does anyone have a question before we can continue? Just erase this. Does anyone have a question? No, uh, I'm saying if they say simplify further, if you've got something like this, they say simplify it further. How can you write it? How can you remove this exponent? Like I did here, I said it's -1. This, if they don't want, if they said simplify further, don't write it in exponential form. You have to write it like this. That's how we did it. So we have got -5 over 3 x to the power -3. So they are saying write it in a ignore those whatever that I deleted, the undefined and everything. Ignore it, because I saw that that undefined confuses a lot of you. Ignore it. That undefined, it was just a number. It was just a random question. So I'm saying my question is this one right here. How can you write it in this form? In a standard form, not in exponential form. Do you get it? Okay. Okay. Because the next examples that we're gonna do, we're gonna apply this whatever that we are doing now. So I think it's a must. You must understand this. When you if you've got something like this, Anthony, uh, when they say write it in a standard form, you must write it like this to the power 3. Do you understand that part? So it's the same thing here. -5 over 3. It's a constant. It's a number, and then you multiply by 1 over x cubed. Is is it my screen? Uh, does anyone have the same problem? Because I didn't zoom my screen. If I uh, yes, it's your side. It's your side. You zoomed in. You zoomed in. Okay, okay. Let's do this. 3x to the power -3. How can you write it in a standard form? This form. Remember, there was a 1 here. There was a 1. There is the 1. So how can you write this in this form? What's the answer? Give me the answer. Thank you. 3 over x cubed. So there's no difference between these two. Sharp, not a problem. So yeah, that's your answer, guys. So does anyone have a question before we move on? Okay, since there's no question, I'll do another example, guys. Let's say you've got integration of, oh, let me just do it like this. Now we're doing division, guys. Integration of 3 over x cubed. dx. So guys, when you've got something like this, when you have got the division, you have to rewrite this in a standard form. You have to write it in a standard form, sorry, not in a standard form, in a exponential form. Remember that formula of exponent, the one that we're using, guys, this formula of x axn dx. You have to write it in this form. If possible, you have to write it in this form. So you have to write it in this form so that you can use this formula. If you can't write it in this form, then you have to use the other formulas, which we're gonna do next week on the next session. I don't want to do those ones because they are a bit tricky. I need you guys to understand the basics of integration. Then the applications will do them next week when we are familiar with these ones. So always when you get something like that, you have to write it like this, guys, to the power minus 3. Do you guys understand it? How I got to this? Thank you. This is what I was explaining previously. So what's the answer here, guys? That's the reason why I was explaining this negative exponent. It's because of that. I knew that we're gonna get to this. So what's the answer here? Can someone, okay, let me pick a random person. I think it's better that way, guys. Guys, I think it's better that way. I think it's better. What happened now? How? Guys, hey. Um, Let me just pick a random person. Morale. Morale, please give me the answer. Let me go back to the question. Ke Morale, ne? There's no way. This is my language. There's no way I can pronounce it wrong. Ke Morale. Morale. Hey. Morale. How? Please give me the answer here. It's 3x. 3x to the power what? -2. Thank you. Plus c, right? So write it in a standard form. Take it back to its original form, not in a negative exponent. Then how do you do it? What's your answer? Take take it back to this. That's the standard form. You see this negative here? It's because of this negative. So take it back to a standard form, to a positive exponent. So wait, I'll help you. Let me help him so that he can understand. Look at this, Mal. Look at this. So do you agree that 3 over 2, we can put it aside and say minus 3 over 2. Then we write this x to the power minus 2 on the side there. Is the same, right? So I think I gave you a hint. Please take it back. That's correct. This always remember this is a constant. They treat these two divides. Remember if you've got something like this, let me give you something. Oh, sorry, I don't want to do it now. I don't want to do it now. But then do you know? Okay, Magali gave me something. I was gonna do it after this one. Do you know that do you know that this 2 is raised to the power x, x2 is raised to the power 0, right? Magali. Okay. Guys, you all know that this 2 it has, yeah. So now, what's the rule of exponential rule? When they are saying dividing the powers of the same base, you subtract the exponent, right? Do you know that rule? Yes. So on the next example, you're gonna apply that rule. Just know that this is raised to the power 0. That's why it does not have any effect to this one. That's why it does not have any effect. That's why your answer it will be just 3 over 2x minus 2. Sorry, plus 2. It has got no effect because this is raised to the power 0. X is raised to the power 0. I'll do the next example, then I'll do the applications of this. That's where we are going, where you divide. That's where we are going, guys. Does everyone understand it? Any confusion? Is everyone sorted? Guys, please talk to me so that I can know that my network is still fine. Yes, no? Okay, thank you. So the next example, I'll just pick someone. It's 3 over root x dx. Okay, guys, root x, you all know that a square root, it's like x to the power of 1 over 2. There is 2 here, but then they didn't write it. Do you guys know that a square root of x is the same as x to the power 1 over 2? Do you guys know that? Okay, so let me ask someone. If you've got cube root of x, what is the answer? If you want to write it in that form, in the standard form. Okay, so thank you. It's x to the power 1 over 3. It's always like that. So after getting the answer, guys, you're gonna get this answer. So basically you went from cube root of x to this. Then after getting the answer, let's say after integrating you get your answer, then they want you to put it in a standard form. You have to go back. You should know how to go back. Do you guys understand whatever that I'm doing now, whatever that I'm saying? If you get your answer in this form, after integrating, you have to take it back. If they say simplify further, you have to take it back to this format, to cube root of 3. Got it? Thank you. Even if it's 4, it's very rare to find 4 there. Okay, let me say, I'm doing introduction to this, guys. Please bear with me. Those that understand it, uh, please be patient. Let's say I've got this. What is the answer for this one? Remember, this one was raised to the power 1 to the power 1. So what's the answer for this one? That's correct. That's correct. 2 over 3. So okay, let's go and apply those. What did I say? Before you integrate something like this, that divides, what do? You put it in a standard form. So you're gonna put it like this. So first thing first, you have to change this. You have to change this. It's gonna be 3 over x to the power 1 over 2. You must write it like this so that you can be able to write it in a exponential form. It's gonna be minus 1 over 2 dx. Do you guys agree? Do you guys agree? Yes, no? Thank you. So the answer that you're gonna get here, you're gonna say 3x to the power of minus 1 over 2 plus 1 over minus 1 over 2 plus 1 plus c. So here you're gonna just go. If you don't know this, you just punch it on your calculator, then you'll get a positive half there. So you'll get 3x to the power of 1 over 2, 1 over 2. So I hope you guys know this. If you want to simplify this further, you see this minus 1 over 2, this sorry, not minus, this positive 1 over 2, and this 3. Take it aside. Let's solve it aside. It's 3 over 1 over 2. If you punch this on your calculator, you'll get 6 for sure. You'll get 6. Do you guys see that? Thank you. So you'll get 6x to the power of 1 over 2. So what did I say? How do you write your final answer? If they said simplify further, what is going to be your answer? Your final answer. Oh, let me erase this, guys. Let me just erase this and write it nicely. We need space. So it's 6x to the power of 1 over 2 plus c. So what's your final answer? If they say write it in a simplified further, basically. So what will be your answer? Hello? Thank you. 6 root x. It's 6 root x. Remember I told you that if you find it, if it's like this, you have to take it back. You have to put it back to the square root. This is your answer, plus c. That's correct. That's correct, guys. Does anyone have a question before we move on? Because we're gonna do applications, guys. Now we are moving. We are moving, guys. Does anyone have a question? Why we like this? But then how can you solve it when it's like this? Remember what I said? Remember on the previous example what I said. If you find something like this, what do? You put it in a standard form so that you can apply this formula right here. You cannot solve it when it's like this. You have to put it in this form, in this format. So there's no difference between this one and this one. The only difference is that this one has got a square root. This, yeah, this is your n. This is your n plus 1. This is your n plus 1. You got to this answer. Do you get it now? Does anyone have a question, guys? Please ask. Even if you want to, even if you've got a sum that you want us to solve, bring it on. Then we'll solve it. Okay. Let's say, guys, you've got let's say I don't want to do, okay, let's say I've got this, guys. It's 3 plus, I like 3, guys, please. I hope you guys don't mind. I'll use 3 all the time. So you've got this. If you went through integration, you'll see that whatever that I'm doing there, it's familiar. So you've got this, guys. So if you've got something like this, guys, what did I say? Before you integrate, what do? You simplify. Always, guys, before you do anything, you simplify. So to simplify this, guys, you see this is your lowest common multiple, this your LCM. This is your LCM. So you can simply say, you can simply break this because this x squared is common. So you can simply write this as 3 over x squared plus 2x over x squared dx. Do you guys agree that this is the same thing? Yes, this is the same. This is the same. Always, always, when you get something like this, please split it. Remember what I said, guys. The aim of doing this thing is for you to write it in a standard form, in this format: ax n plus 1 over n plus 1. Sorry, let me remove this integral sign. This is the answer that you should get. That's the reason why we change everything to that format. This is the reason why we want it to be in this format. So now, so now, guys, remember what I said. Because of this bracket, it means everything it's integrated inside the brackets. So now we'll take this down. We'll take this down. I'll write it here. So what you're gonna do there, this is the basics that we did, guys. We wrote 3x to the power minus 2. Sorry, minus 2 plus. Do you guys? I hope you guys know these rules of exponential rule. What are you gonna get here? What are you gonna do? You're gonna say, let me open bracket here. You're gonna say 2x to the power of 1 multiplied by x to the power of minus 2. Do you guys understand this rule, the rule that I applied here? Yes, that's your exponential rule. Please let me know if you don't understand it. Please let me know so that I can explain it to you. Please ask. No, you can give the answer. If everyone understand, yes, what's the answer? Which which answer? Which one? The whole question. Negative 3x to the power negative 1 plus, you only solved this one. Okay, please let's write everything down. Let's solve it together. You said for the first one, for let's solve this one. What did you get? 3x to the power negative 1. Okay, I wrote that negative there. And then plus. Okay, so here it's plus 1. So what happened to this 2? Yes, we are here. Let's solve it here. Let's solve it on the side. Simplify it first. What did you get? Before you integrated, you need to simplify this. What did you get? How did you get that? Let's solve this. And Anton, let's solve this. Let's leave out the 3. Let's leave out the 3. We are here. We need to solve this. We are done with 3. Ignore 3. We are here. We are in this part. We're in this part. How did you solve this? How did you solve it? Okay, so you're saying this is 2 to the power minus 1 before integrating, and differentiating. So when you integrate this, so basically you're gonna go and say integration of this, then you're gonna get 2 to the power x minus 1 plus 1 over minus 1 plus 1. Then obviously because of this is 0, it's very rare, like I said earlier on, that not a problem. Not a problem. So I told you guys it's very rare for you to find undefined. It's very rare to find undefined. Then they will never give you something like that. So the answer, if we don't ignore that undefined, don't get confused. That undefined, just leave it, just ignore it. Anything divided by 0, it's undefined. So you'll never get this. So your answer will be minus 3x to the power minus 1 plus undefined. Let's ignore this undefined for now because I'm trying to show you guys. The aim is to show you guys how to solve these things. So here you're going to get minus 3 over x plus that undefined. We just write it just for, there's no need for you to write it. We're just writing it because, yeah, we got 2 over 0. Do you guys understand that part? Oh, yes, plus c. Thank you. Don't forget that. Plus c. Plus c. Other than that, do you guys understand it? Yes, ask. Where do you, when, okay, let me show you something. So, you see, let's go back to the formula sheet. You see formula number 1, that's what we are doing. Formula number 1. Do you see it? It's on your formula sheet. Yes, you see it has got dx there. So they are saying your left hand side, that's your question. So the answer that you must get, it's on the right hand side. Do you see that? And then when you write your answer, there's no dx. This dx means you are integrating with respect to x. So the moment you integrate, you throw away that dx. Then you write your answer using this right hand side equation. So your answer must be like this. Let me just show you because you arrived late. Guys, please let me just assist there. So let's say I've got x cubed. So applying that formula, there's dx here. This dx means you're integrating with respect to x, right? So the answer that you're going to get here, you're going to get x to the power 3 plus 1 over 3 plus 1 plus c. This is the answer that you should get. After integrating, this is the integration. Yes, you put plus c. Yes, that's what you should do. Anyone who's got a question, guys? Sharp, not a problem. Anyone who's got a question? Please ask. Ask. Please ask before I do the next example. Okay, no question. Then let's say you've got, I'll just write the same equation just to save time. 2x. Okay, let me just do this, guys. I want to make it a bit complicated. 2 root. Okay, no, this is simple. Let me do this. I'll do this, guys. Just because I like you guys, I'll do this. Just because I like you guys. Just because I like you guys. Can someone simplify this? Yes. Okay, wait, let me write it. Okay, let me write it. You're saying what? X to the power 4 over 5. When you, when you multiply this, when you simplify this is the same. Okay, let's say they said integrate. Thank you for raising that question. Thank you. If you've got something like this, they said integrate. This is the same as 1 over 5. Remember, this is a constant. There's 1 here. There's 1. This is the same as the ones that we're doing. So this is the same as 1 over 5. Integration of 1 over 5 multiplied by x to the power 4. dx. Do you agree that is the same thing? Yes, so this is your constant. So ignore the constant. The constant, will write it as it is. It's 1 over 5. Then x to the power, you deal with this 4. X to the power 4, 4 plus 1 over 4 plus 1. So plus c. So your answer will be 1 over 5 multiplied by, I'm just doing the multiplication so that you can see the difference, 5 over 5. So basically when I multiply this by this, then this by this, so you'll get x to the power of 5 over 25 plus c. This is your answer. Do you get it? Yes, I think we did a problem like this one. I think we did a problem like this one. Let me just go back. I think we did it where I asked, yeah, this one right here. This is the same problem, I think. Yes, this is the same problem. This is the same problem. The only difference is that in this case, you're multiplying by x. That's the difference. You're not multiplying by a number. So, but then if you're multiplying by a number, you multiply by it, by that number. So I hope that makes sense, guys. I hope it makes sharp, not a problem. So let me find someone to ask. I need to find someone, guys. Please hold. Please wait. I'll go to the meeting. Why? I can't see all of you guys. Wait, let me do this. I need to see everyone. I'll go to Elizabeth. Elizabeth. Yes, thank you for responding. How do you, please simplify this. Sorry. Okay, okay. No, 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 no. You see this okay, let's go back. Where is that question? Remember what I said. Uh, do you see this? This positive. Do you see this positive? Elizabeth? Hello? Hey, is it my network, guys? Or it's not my network? Okay, no, Stanley. Stanley, since. Okay, Elizabeth, okay. I nearly got someone to help you. So, remember what we had? This 2x over x maybe. I can't remember the equation, but then let's just write x just for in case. When we had something like this, Elizabeth, what did you do? The previous example was like this. Let's do it step by step. We did this. We did this. We simplify first. Thank you. We cut here. We said 3 over x plus 2x over x is the same as this. Then from there, you write this as a standard formula, minus 1 plus this x and x will cancel, so you'll get 2. Then that's when you can integrate after doing this. You write it in the standard form. Do you understand this part, the part that I did now? Elizabeth, do you understand the part that I just did now? I think Elizabeth network has got a problem. So okay, it's going to be what? It's going to be what? Elizabeth, your network. Okay, let me find someone to do it. Stanley, please help. Yeah, it's your network. Stanley, please help. Or is it my network, guys? Stanley, Stanley, when you did these things, I know you. You did these things at college. I know you, and you don't know that I know you. Okay, let's go. CJC. CJC, I know you. You're doing mechanical. I know you, bruh. we'll, we'll talk. Don't worry. Sharp. Let's talk. Let's go. What do you do then? What do you do? Stanley, give me the answer. Yes, what's the. Okay. Yeah, this 2 is multiplying. Let me write it nicely. I'll write this 2. Yes. And then over x. And then what are you going to get? I want you to give me the final answer. Yes. Look, you see this? These are dividing the parts of the same base. Yes. Okay, then you're gonna get minus 3 over 4 when you subtract those values. The values that you gave me, you're gonna get minus 3 over 4. Yes. And then from there you integrate. It's in a standard form. Okay, sharp. Thanks. So from there, no, it's fine. You can mute your mic. We are done. Thanks, Stanley. So you're gonna get 3x to the power minus 1 plus 1 over x. Sorry. Remember what I told you guys? You'll never get a sum like this. I'm just doing it just to show you guys. It's an example. You'll never get a undefined where you get a 0. I'm just showing you guys how to solve this thing. I'm just coming up with the sums. So it's 2x to the power of, okay, minus 3 over 4 plus 1 over minus 3 over 4 plus 1. So this one, oh, sorry. Let's just write here. Let me just erase everything. So ignore that undefined. I'm just coming up with the sum. Ignore that undefined. So let's solve this here. So you're going to get 2x. So you're going to say minus 3 over 4 plus 1. So you're going to get 1 over 4 over 1 over 4. So remember what I said. You take this 2 as a constant, these values. So you can simply write this as 2 over 1 over 4, then multiply by x to the power 1 over 4. So when you solve this, you're going to get 8x to the power of 1 over 4. So I told you guys that if you get this, you have to take it back. So you'll get 8. Okay, let me just open the bracket. 4 root x plus c. Do you guys understand it? Do you Sharp. Does anyone have a question? The session is almost over at half past. Does anyone have a question? Does anyone have a question? I think we covered a lot of things today. Does anyone have a question? Before we can wrap up, even those who arrived late, I'm willing to assist you. I'm willing to explain to you guys if you want clarity somewhere. Does anyone have a question? Yes, no? Hello? Okay, so everyone is fine. Okay, so let's just pick one example from your study guide, then we should wrap up. Okay, let's do this. Study guide, wait, not this one. The study guide. We covered this. Guys, we've covered a lot of things. You see that we've covered number C, A, B, C. Guys, we covered this. Look at this, guys. Amazing. Amazing. You see they left this answer in this form. If they didn't say simplify, you can leave it in that form. It's up to you. If they specified, then you see this, guys. We did these things. So basically, we covered everything here. We covered everything. Oh, what we didn't cover is this one. I think I should show you guys this one. Should we do it? Okay, but otherwise, guys, do you see that we covered a lot of things? We covered everything that is here. Activity 2, you see that? But then I didn't do this activity. I just came up with the sum. I just did random questions. So I'll get back to that F. You see we did this, guys. This example 2. We did cover this example 2. This is your constant. Sorry, this 7. Can I highlight this 7, guys? This 7 is a constant. So how do you integrate a constant? You'll see they got 7x. Do you see your answer there? There is your 7x. Do you see that, guys? We covered a lot of things today. You see, they're integrating this. You'll get 3x to the power 3 over 3. Then you'll get cubed. You see, guys, we did a lot of things. You see that? No, a constant is a number without a function. A constant is a number. When you have x, the moment you have got x, it's not a constant. A constant is a number. There is no way x can be a constant. The moment you have a constant, the moment you have a x in your equation, it's not a constant. I did explain that, I think, guys. Am I right, guys? Didn't I explain that? I think it's this part here where I was explaining the constant. It's this one. Wait, show you just now. I did explain that. Yeah, it's this part here. I did say where we have a as well. We've got a somewhere. Yes, I did say that if there's no way you can say uh, a constant is a number. A constant is a number. There's no way you can say this. Where is that thing? Oh, my pen is off. It's off. There's no way you can say this. This is a constant. Never. A constant is a number. The moment you get this, there's no way this can be a constant. It's a function. A constant is a number. It's a, it's b, it can be anything. It's lean, it's 3, it's any number without x. If you get 3x, it's not a constant. A constant is 3, but you've got a function of x there. So this cannot be a constant. Okay, Anton. What is the integration of this? Of this? Please don't confuse the two. Please, Antonio, so that you don't get confused. Always when you get something like this, don't try to answer to get to the answer. Simplify it. You'll get to the answer after simplifying. That's how you memorize these things. Because if you confuse yourself with the constant and what, you'll get confused. Just do it step by step. So you see, you are done with this step. Move to the next step after that. The next step is to do what? Yes. Then that's your plus C. Then that's your answer. So sure. So yeah, this is how you do it. So I was here, guys. Sorry, I was here. So guys, we covered a lot of things. Look at this. You covered everything basically. Remember what I said, guys? I said if you get dt, it means everything is differentiated, is integrated with respect to t. Do you guys see that? You've got 3 t squared. The reason why they put that t, it's because of your dt, because of this dt. So, for instance, they can give you, we're not going to do this trigonometric ones today. You see that question of yours, Anthony? You've got root 3. Root 3 is a constant because it does not have a function of x. So they just put x to the power 0. Remember what I said? If you've got a number alone, you add x to the power 0. We covered this. Remember, guys? Guys? Yes, because of x, a constant is raised, it has got x to the power 0, like I said. So we covered this. We even covered this 1 over x squared. We even covered, guys, we covered a lot of things. Basically, that's all I'm saying. We covered a lot of pages. There's no need for you to do this thing. Then next session, we're going to do this, guys. We're going to do the applications where you have to multiply out. We didn't do the multiplication. Remember I said we do addition, subtraction, division. So the multiplication, we're going to cover it on the next session because it's almost time up now. We'll cover it on the next session, multiplication and applications. So we did cover this, guys. Look at this. We did cover this. Where is it? I saw something dividing. Oh, it's gone. Oh, we did cover this. Am I right? We did cover this. Number B, where I said, what do? You split. You're going to say, you divide everything by 6. Do you guys see that? We covered a lot of things, guys. The only, I gave you like a lot of things, guys. Basically, I gave you like more than 20 pages of the study guide. So, yeah, it should be fine, guys. Let's do this one. I'll not do that one exactly because I cannot use those examples. I have to use, because I'm going to upload this on YouTube, so I cannot use their examples. I have to use to come up with the examples. They will say it's piracy or something of that nature. It's x. Okay, let's say I've got x to the power 3 dy. What did I say about this, guys? What did I say about dy? What does this dy mean? This is the last example. Okay, let's start here. Okay, let's start here. I wanted this to be our last example, but then what's this? How do you get the answer here? What is the answer? What did I say about this dy? This dy here. Remember I said this can be anything. It can be dt, dx, dy, dt, d what, dz. It can be any alphabet you can think of. So that's correct. That's correct. You are integrating with respect to y. So your answer is it's y. So look at this, guys. So now we are different. We are integrating with respect to y, not x. So our value of x is a constant because we don't want to integrate with respect to x. We want to integrate with respect to y. So we're gonna treat that x. That's when, Anthony, like your question, the question that you asked, this is when you treat x as a constant because you're not integrating with respect to x. So right now your answer is gonna be, remember, we want y, the value of y. So this is the same for this. Okay, let me just erase this. All right, nicely. I want to show you guys. For this 2, it was raised to the power 0. Sorry, not x, man. It's y. How? This is y. Y to the power 0 dy is the same as integration of 2 dy. So now we added 1 here. So this is the same. Just because we're integrating with respect to dy, we're going to say x is our constant. And then we got y to the power 0 dy. Does this make sense, guys? Does this make sense? Thank you. This is the same as this. So what's the answer? What are you going to get? So what's your answer, guys? What's the answer, guys? Treat x cubed as a constant. I told you that you ignore that. Okay, x cubed is like 2. It's like 2. Maybe to make it simple, it's like a number. It's a constant. So what's your answer? Yes, that's correct. X cubed y plus c. Why not? This is your answer. This is a constant, guys. You don't want this. You don't want to use this. You don't touch what you are not supposed to touch. You only work with y. You don't work with x. They told you here that, my guy, please work with y. Ignore x. We don't want x. We want y. Don't touch x. Touch y. So treat x as a constant and integrate y. So treat x as a number or any function that is constant. Do you guys get that? Thank you. Does anyone have a question before we wrap up the session? I think we've covered a lot of things, guys. You can go and answer your what do you call it? Your you can start practicing. At least now you have a clue of how do you integrate. That's the aim. That's the main thing. Now you know how to integrate. So now you can go and do practice those, prepare for your assignment, basically for assignment 4, or you can just practice. If anyone has got a question, please ask, even if it's from your, is it assignment 3, if you, where you need clarity. I did upload the video for that can guide you for your assignment. Is it assignment 3? Yes, for your assignment 3. So please